This is Mr. Leader here. This is section 7-3. Whoops, no, already made a mistake. It's section 5-3. Okay, and this is factoring out, factoring, that says factoring out the GCF, okay, from an algebraic expression, and GCF stands for greatest common factor, and I think you've done this before. So I want you to take notes as we're going, and I want to see your notes tomorrow in class, and you'll also get some awesome jokes, and if you can tell me the answers to both of those jokes, I'll give you an extra point. Okay, just to keep you on your toes. Greatest. All right. So, you probably already know that if you have an expression like this, 64 plus 4 in parentheses, this is kind of the opposite of multiplying, because one way, when we're solving algebraic equations, factoring becomes really important, because when you factor things out, you can solve the algebraic equation. So if you have a 64 and a 4, both of these contain a 4, so I can pull out the GCF, which probably you guys already know, which is 4, and since 4 times 16 gives you 64, and 4 times 1 gives you 4, I could rewrite this expression as 4 times 16 plus 1. Why would you want to do that? Well, in this case you wouldn't, but with algebra you do, okay? To solve an algebraic equation, okay? But we'll worry about that later on. So if I write this, 8x squared plus 20x, you can think of this, right, as you want to pull out the greatest common factor out of each of these. So there's the greatest common factor in 8 and 20 is 4. So I could pull that outside the parentheses. And it's 4 times 2 times x, okay, plus 5 times x, right? Well, since both of these expressions, right, because 4 times 5 is 20, and since both of these expressions have an x in them, I can pull that x also outside of the parentheses. So completely factoring out the GCF, I have 4x times 2x plus 5. And that's factoring out the greatest common factor from an algebraic expression. And like I said, we'll use that later on to solve equations, okay? This thing right here, this 4x, this is called the greatest common factor, okay? Here's my first joke. I'm not going to reveal the answer until later on in this cutting edge video, okay? Here's a joke. What do you call a boomerang that doesn't work? Okay, think about that for a while. Okay, so now it's time for you to try. I want you to try these on your paper. I want to see that you have tried it, and I'll give you a minute. So you try this. Try to pull out the greatest common factor from this expression, okay? 4mn squared minus 12m squared n. Okay, give that a try while I pause here. Whoops, pause here for station identification. Okay, hopefully you tried that problem, and hopefully if you tried it, you should pause the video when I say pause and try to do the problem, okay? So if you did that problem, you should have factored out now this thing. I can pull out a 4 from both expressions, right? And then I'm going to do it in 2 steps, and then eventually you'll get good at this, and you can do it all in one chunk. But I can pull out a 4, and this I can rewrite as m times n minus 3 times m times m times n, right? And so you can see that inside the parentheses I have the letters that I could pull outside is 1m here and 1n there and 1m here and 1n there. So I'm going to pull those outside my parentheses, and now I have 4m n times n minus 3m is what's left out. And hopefully you did that on your own. What's the answer to my riddle? A stick. Okay. Hopefully you heard the riddle earlier. I'll tell you another one later on. I know it's got you on the edge of your seats. Okay, my printer is making noise, sorry. Okay, I'm back. Moving on, let's do a more difficult one. Let's get a new sheet of paper. Okay. And let's do blue, because blue is my second favorite color. And so now you guys are going to try this one. 6x squared y cubed plus 20x cubed. 20x cubed, that's an x. I guess this Moby board does the same silly thing as my other one at school. That's an x cubed, just in case you can't see it. X cubed, y to the 8th, y to the 8th minus 4 x to the 5th y squared. X to the 5th y squared. Okay, pause the video, write that one down, pause the video, and give this one a try, okay? Okay, we're going to move on. So hopefully you got that one. You can tell that the GCF and the numbers, I can do this one all in one step. So the biggest thing I could pull out of 6, 20, and 4 is a 2, correct? And you look for the highest variable that is in all of these. And it looks like my highest x term is x squared. So I could pull that outside. And my highest y term that's contained in all three is y squared. So I could pull that outside too. Right? And now I can rewrite the inside factor, which is going to be 3, right? Because 2 times that gives you 3. This x squared, I just need to multiply that by 1 to get that x squared. And y squared times y will give you y cubed. So there's my first term. My next term is going to be 10x. Wow, this Moby board does the same thing as the other one does. 10x y to the 6th. And that's the second term, right? Because y to the 2 times y to the 6 gives you this y to the x, y to the 8th, and x squared times x gives you x cubed, minus, that's going to be a 2x cubed, no y, right? And then we're done. All right. So that's enough u-tries for now. Okay. Now sometimes we have a negative that we want to factor out, because a lot of times in algebra you'll have like a you'll have an equation that you're trying to solve, and it's kind of a pain to have a negative in there because negatives are confusing, and I don't like to be a negative person, so I try to make things positive. All right. And so with this one, I'm going to say factor out a negative. Factoring out a negative. Don't worry, I haven't forgot about your next joke yet. Okay, so factoring out a negative, I am going to, there's a negative 1 in both of these, so I'm going to factor out a negative 3 out of there, and negative 3 times x will give you negative 3x, and negative 3 times positive 6 will give you a negative 18, and that's how you do that one. Okay, so let's do another one with a trinomial. Okay, that was a binomial. Okay, and so with this one, let's try this one, and then we'll do a couple you tries. So we got negative 5x squared, negative 5x squared plus 2x minus 1. So I want to factor out the negative from all of these. Well, there's no negative, there's no common constant factor that I could pull outside. So I'm just, in this case, I'm just going to pull that negative sign outside. So I'm going to put a negative out there. And then this is just going to be 5x squared minus 2x, because a minus times a minus would give me this plus 1, and then I factored out the negative from that expression. Okay, you ready? You try. Okay, and after this I'll tell you my best joke of the year. Okay, it's not really that good, but maybe you'll laugh. Okay, but it's keeping you on the edge of your seat, I know. Okay, so you try. Let's try a different color. Negative 3x squared minus 4x plus 7. Factor out the negative, okay? Ready, go. I'm going to pause this. Okay, if you've tried that one, you should have gotten negative, 3x squared plus 4x minus 7, because minus makes a plus, minus plus makes a minus, and minus that will give you that. Okay, one more you try, and then we're going to move on to bigger and better things, okay? So try this one. Let's try green this time. Negative 3a to the 4th plus 6a to the 7 minus how about 9a. Let's just leave it at that. Okay, you try. You try. There we go. Okay, I'm back. And if you factored this out correctly, the biggest, greatest common factor that I could pull out, and a negative at the same time, I'm going to pull out this negative 3a from all these, because I could pull out an a from everywhere. That's the highest degree term I could pull out. And I could pull out a 3, but I'm also going to at the same time pull out a negative sign. So this becomes negative 3a times a cubed. Becomes negative 2a to the 6, and this becomes plus 3. Okay. Uh-oh, someone's trying to print again. No, they're not. That's okay. Okay, don't mind the printer in the background. Okay, here's your joke. What do Eskimos get when they sit on icebergs? Okay, that's your next riddle. I'll answer that one at the end, towards the end of the lesson. All right, one more thing that we're going to try. And this is an expression involving 4 terms. And this is one way that you can factor a higher degree polynomial with more than 3 terms. Okay, you can break it into pieces. So if I see And we'll learn later on a technique called factoring by grouping. Okay, and this is kind of where that leads to an expression with four terms. Four terms. Whoa, that is messed up. I figured out. Okay, here we go. A message with four terms. Um, okay, maybe if I talk in this accent, you'll hear me better. Or I can talk like Donald Duck. Okay, that perk you up? Okay. In any case, I can talk with an English. No, that's not very good. Okay, moving on. Mr. Leader, so weird. Let's try pink. Okay. I'm going to look at the first two terms independently and then at the second two terms. You say, oh, there's nothing I could pull out of all these four things. That's true. I can't pull out anything out of all four of those terms, but I can pull out the same thing out of the first two terms and the same thing out of the second two terms. What is that thing? Well, in this case, you can pull out an a squared out of the first two terms, okay? And that becomes a plus 5, okay? So this times this expression gives you this part right here, okay? So I'm going to look at this first, and then I'm going to look at the second part of it, and you say, what can I pull out of both of those? Well, you say a 6 can be pulled out of those. 6 times what? 6 times a plus 5. Now, look at this. This is very interesting. Here I have an a plus 5, and here I have an a plus 5. So, you can rewrite this expression as, okay, a squared plus 6, that whole thing times a plus 5. It's kind of like the opposite of foiling, because if I foiled this, I would get this expression, right, because a squared times a would give me my a cubed. 5, there's my 5a squared, here's my 6a, the two inners, and my two last would give me a 30. Okay, another way to think of this is as kind of doing the thing we did with the box method in reverse. So I'm going to draw a little box here, okay, and in my top part of my box, I'm going to put my first two terms. Now, when you do this, you kind of have to group the terms that have the same common factor together. Okay, so I'm going to put my a cubed here and my 5a squared. This is just another way to look at the same problem if you don't see where I got this from. Okay, and then down here I'm going to write my 6a plus 30 down here, and then I'm don't do that. All right, 30. And then what I'm going to say is, what can I pull out of this row? Well, if I look at this row, it seems that I can pull out an a squared and put it over here. See that? Because both of these terms contain an a squared. And then you say, what can I pull outside of this row? Looks like I can pull out a 6 out of both of these terms. And then I kind of go backwards. You can either say, what can I pull out of this row and go up? Or I can just say, what do I need to multiply a squared by to turn it into a cubed? And you say, that's an a, right? Because a squared times a would give you a cubed, and 6 times a would give you 6a. Over here, okay, you say, what do I need to multiply a squared by in this width right here to give me 5a squared? Whoops, there's my phone. I'm going to pause for a second. Okay, my phone stopped ringing. That was the president. He wanted some advice. In any case, so now I'm going to put a 5, just 5 right there, right? Because a squared times 5 gives you 5a squared, and 6 times 5 would give you this 30. So you can see that here is, these are the same two binomials, a squared plus 6, there it is, and a plus 5 is this one up here. So this expression inside the box, if I foiled this times this, I would get this. which is equal to my original expression. Okay, so you could either do it by grouping, kind of like I did here, or by putting the values in a box, like I did there. Okay, so you guys, you smart kids out there, are going to try this one. Oh, what was the answer to my joke? Oh, the answer to my riddle was Polaroids. Polaroids. You get it? The question was, what did Eskimos get from sitting on a block of ice? Think about that one. Okay, we're going to try, you try. You try, and then we're going to be done. Okay, so here is a somewhat more complicated expression. Not really. It's going to be green, so we're going to put a 18m squared, 18m, that's an 18m squared, plus 12m minus 6m minus 4. Okay, so you can either put these two terms in the top box and then pull out a factor, and put these two terms in the bottom two boxes and then pull out a factor. See what you get. Give that one a try. I'm going to go get a cup of coffee. Okay, I'm back. So if you did this one, you should have got 6m minus 2 times 3m plus 2. So I looked at these first two terms and I said, oh, the greatest common factor in both of these constant, or the number, is 6. So I could pull a 6 outside, but I could also pull an m outside. Okay? Times 3m, because that makes 18m squared, plus 2 makes 12m. Then out of these next two terms, I could pull out the negative sign, okay? And I could also pull out a 2 times 3m plus 2. Notice, again, this 3m plus 2 is equal to this 3m plus 2. So I could rewrite this entire expression as 6m minus 2 times 3m plus 2. Let's do it with the box method, because that might be a little bit easier for some of you. So let's look at this. So in the top box, I'm just going to put my 18m squared plus 12m, okay? And in the bottom box, I'm going to put minus 6m minus 4, and then I'm going to look at this row. What can I pull out of there? Well, I could pull out a pink 6, and I could pull out a pink m, right? And out of this row, I usually want to pull out the negative sign, because that makes my life a little bit easier. Okay, and I could just pull out a 2 from both of those, right? And then I say, okay, I could look at this and say, oh, I could pull out a 3m this way, or I can just say, what do I need to multiply 6m by to make it into 18m squared? Well, that's a 3m, right? And that would be the same as, what do I need to multiply negative 2 by to make it into negative 6m down here, and that as well as a 3m. Okay, then I come over here and I say, what do I need to multiply 6m by to turn it into 12m? That's a 4, right? And then what do I, and then you're pretty much done. I mean, 4, uh-oh, what happened? Wait, 6, oh, 6 times 4 is not 12. See? Even Mr. Leader. That's the first math mistake I've ever made. Okay? That should be a 2, right? You're saying that, Mr. Leader, not very smart. Okay. So, so this should be a 2, not a 4. So 2 times 6 gives you 12m, and 2 times negative 2 gives you negative 4. And then here are my two factors, which I can write as 6m minus 2 times 3m plus 2. And it doesn't matter, since multiplication is commutative, it doesn't matter which order you do it in. Okay? And that is the end of today's video. Please save these notes and show them to me tomorrow in class, and write down the answers to my riddle for an extra point. And your homework is Math Excel. Math Excel 5-4, I believe it is. 5-1, 2, 3, 5-3, sorry. And please show your work on a separate sheet of paper. Okay, thanks. Signing out. Bye.